Hello everyone, this is Athreya and welcome to our channel CodeChef. Today we're going to be solving the problem Subtraction Game, and to solve this problem we need to have the prerequisite of knowing greatest common divisor or GCD. So as usual, let's get started with reading the problem statement. Here we are given a sequence of n integers here a1, a2, a3 and an, and the game is as follows. If the numbers are equal, the game actually ends. Otherwise, we select two numbers that are unequal and we subtract the smaller number from the larger number. For the sake of simplicity, if I have n equal to 2 and my a1 and a2 array elements are, let's say, 10 and 2. So to play this game, I'm selecting two numbers. These are unequal. I have only two numbers, so my operations are forced. And I subtract the smaller number from the larger number. If I subtract the smaller number from the larger number, I get 10 minus 2 equal to 8. Replace the larger number with this result. So this 10 becomes 8 and this 2 remains the same. So we keep doing this. So now again, this is the larger number. So I do 8 minus 2, this becomes 6 and this remains 2. This is again larger number. I do 6 minus 2, 4, this remains 2. This is again unequal, this is a larger number. I do 4 minus 2, 2 and 2. Now these becomes equal and our answer should be 2. So this is what it tells. When n equal to 2, our operations are kind of forced. We have to pick these two elements as long as they are unequal and keep performing the operation by checking which is the greater, subtracting the smaller number from the greater number, replacing it and repeating it. If there are two elements basically, but there can be n positive integers. Now Jeff has figured out that this game always terminates. He also knows for a given sequence of integers, the game will always terminate on the same value. This is the important part. So the game always terminates, and the game always terminates at the same value. Now, no matter how the game is played, so no matter what you pick at the end, if you have like n elements and you're starting out with a1, a2, a3, and each iteration you're going to pick two of them which are unequal and do this operation what I've showed you here. And after the end of all this, no matter how you play the game, you are left with all the same elements. It terminates in the same values. Like all of these are k values, k, and this k is our answer. And no matter how you play the game, always you will end up, the game will terminate, and the game terminates on the same value. This same value I noticed as k. I've just noted it as k. Now Jeff wants you to simulate the game and tell him on which value the game will end. So let's look at a sample case. Here basically we have two elements, 10 and 12. So this is kind of forced, like I told you. If n is equal to 2 is kind of forced, which is a larger number, 12 is a larger number. So I'm doing 12 minus 10 is 2. Then after that I have 10 here. So now 10 becomes the larger number. So I do 10 minus 2, 8. Now 8 is still the larger number. I do 8 minus 2, 6. Now 6 is a larger number. I do 6 minus 2, 4. Then 2 remains the same. Now 4 is a larger number. I do 4 minus 2, 2. And this is 2. Now these are no longer unequal. So our answer is 2 for the first test case. Now what I've done is first in each iteration pick two elements. In this case the only two elements you can pick are the two elements given to us. Take the larger number and subtract the smaller number from it. So this is 12 is my larger number. I've subtracted 12 minus 10, it becomes 2. Immediately after I do this, 10 becomes my larger number. So I should do 10 minus 2, so on and so forth. Now this what you have done is basically Euler's method of finding the greatest common divisor of two numbers. So if you notice, the greatest common divisor of 10 and 12 is basically 2. 2 is the largest integer that divides both of them, 10 and 12. The greatest common divisor, what you call it. So this method, what we've seen here, is exactly Euclid's method of finding the greatest common divisor. Oh, I wrote Euler, but Euclid's method of finding the greatest common divisor. Because GCD of A comma B is the same as GCD of A minus B comma B. If I assume that A is greater than B, basically. So this is the same. For example, if I do GCD of 10 comma 2 or I do GCD of, let's say, 8 comma 2, both of these are basically the same thing. This kind of a recursive approach where you find out the greatest common divisor of two integers. Once you do this multiple times, you get the answer as 2, because the greatest common divisor of 10 and 2 is basically 2 itself. However, now again we have 5 and 9. Just by looking at this, 5 and 9 don't have any common factor. So the highest common divisor of 5 and 9 has to be 1. But now let us look at this interesting case where are n equal to 3. That's why, GCD was the most common prerequisite for this problem, because greatest common divisor, if you know it, and you know that greatest common divisor is computed by this way, by Euclid's method, then it's very simple to know that this is just reducing the problem into finding out the greatest common divisor of all the elements. If I have 6, 10, and 15, let me do two ways, okay? First, I'm picking 6 and 10, these two elements which are unequal. 10 is my larger number, so I have to do 10 minus 6. This becomes 4, this becomes 6, and this becomes 15. Now, I'm picking, let's say I pick 6 and 4. When I pick 6 and 4, 6 is my larger number, so I get 2, 4, and 15. Now, let's say what I do is I pick 2 and 4. If I pick 2 and 4, now it becomes 4 is a larger number, so it becomes 2 to 15. I can no longer pick 2 and 2 because 2 and 2 are equal. I should pick two unequal integers. I'm picking 2 and 15. This becomes 13. This becomes 2. This becomes 2. So 2 to 13 basically. Let me continue it here. And I'll just make a box so that it's simple to understand and write an arrow here. Now after 2 to 13, what I'm picking is 2 and 13. If I pick 2 and 13, now 13 is a larger number, so I have 11 here and 2 here. Now I'm picking 2 and 11. So 11 minus 2, 11 is a large number. These two are unequal. 11 minus 2 is 9, 2, 2. Now then 7, 2, 2. Then 5, 2, 2. Then let's say this is now 3, 2, 2. Then it becomes 2, 2, 1. Now if I pick these two integers, 2 is a larger number, so it becomes 2, 1, 1. Now if I pick these two, 2 is a larger number, 1, 1, 1. So I end up with 1, 1, 1 here, and my answer is 1. No matter what, suppose I started with what, 6 and 10 first. I suggest you pause this video and do the same process by taking different orders of pairs. For example, I took 6, 10, then I took 6, 4, then I took 2, 4. Like I want you to pause the video and take 10, 15 first, and then take different pairs. After you do 10, 15, maybe do the 10, 5 pair, or then do the 10, 6 pair. It's your wish, but take different orders of pairs than I've taken here, and always your answer will come down to 1, 1, 1. Now you can also think of this as we've established that GCD of A and B is done by this method. Now 10, 6 and 10 is here, right? 6 and 10. So the reason I pick 6 and 10 continuously is to show you a important aspect that here, look at these four boxes that I've drawn. 6, 10, 6, 4, 2, 4, and 2, 2. What basically happened in this 4 iterations when I kept picking up 6 and 10 is at the end of 4 iterations, I've got the GCD of 6 and 10. GCD of 6 and 10 is nothing but 2. That's what I've got here, 2 and 2. When I picked it 4 times. First time when I picked it, 10 was a larger number, so 10 minus 6 is 4. Then 6 is a larger number, 6 minus 4 is 2. Then 4 is a larger number, 4 minus 2 is 2, and becomes equal. So what I did when I picked up two numbers as a pair and continuously picked up that pair again and again and again was, at the end I got the GCD of 6 and 10. That is 2. Then with 2, I have 15. So this whole problem reduces of GCD of 6, 10, 15. I mean GCD of 6, you can write it like this also. If GCD takes only two numbers as a function, so you can compute the GCD of 6 and 10. Then you compute the GCD of 6 and 10 with 15. This is nothing but the GCD of the whole array itself. So the approach to this problem is very simple. We will just find out the GCD of all the numbers in the array. Of all numbers in the array. Hope this part is clear. Now let us look at the code for the approach that we have just discussed. Here what we're doing is we are inputting the array elements here after inputting n, and then we are just computing greatest common divisor of the whole array. Now if we want to find out the greatest common divisor of 4 integers or 4 array elements, let's say n is equal to 4, and we want to find out GCD. Now GCD is a function like min and max that takes 2 integers and gives a GCD of that. So to emulate this is nothing but we find GCD of A and B first. Then find the GCD of do the GCD of A and B with C. Then you want to find out the GCD of ABCD, so you wrap this up in another GCD and you do this. So by doing this, what we're just doing is we can utilize the inbuilt function of GCD, which takes in 2 integers and returns the GCD of those 2 integers, and club it with the other integers so that at the end we have GCD of all the elements in the array. So first you found out GCD of A and B. Then when we find out GCD of A and B with C, this is basically GCD of ABC. Now when you do the GCD of ABC comma D, it's nothing but GCD of the whole array. This is kind of the process that we followed here, where we find the GCD of all the array elements and then we output the total GCD. That's it. Hope this is clear. Hey guys, that was it. Thank you so much for watching this video, and if you haven't yet done this, this is a gentle reminder to hit that subscribe button. If you're interested in competitive programming and data structures, this channel is a one-stop solution for you. See you in the next video. Bye.